Okay, so we're going to look at example 4. So if you take a look at example 4 just gives you a straight up function. Okay, and there's a lot of transformations going on. Like, we've got a movement to the left too, because there's x plus 2 in the denominator. We have a movement of down 1 from this negative 1 on the outside right here. I've got a stretch from the 4, and I also have a reflection. Okay, so those are all the transformations. All right, so when you do, again, you do the vertical and horizontal asymptote. The vertical and the horizontal asymptote really just come from your left-right movement, your up-down movement. So that vertical asymptote is, since it's gonna go to the left too, okay, so that means it's gonna have an equation of x equals -2. So you can see that in the red right here. And the horizontal asymptote, since this bad boy goes down 1, we got to shove that horizontal asymptote down 1 unit, so it's going to have an equation y equals -1. All right, so if you hadn't noticed, vertical asymptotes equations x equals something, horizontal asymptotes equation y equals something. Just depends on the transformations. And that's pretty much it, okay? So I've got my vertical asymptote, that's that red line. Got your horizontal asymptote, that's that blue line. All right, and if you take a look at the curves here, the curves are in a different position, and that's because of the reflection. So if we're going to go take a look at the parent function, so going back to the calculator, you got your parent function in black, okay? And then the function that we're looking at, that's that -4, the new one from this example. The curves are actually in different spots, okay? And this red line, that straight red line right there, okay, that's just the asymptote, all right? So if we go and take a look at that, remember, again, you are just quick graphing these green curves for the hyperbolas. You're not doing exact numbers. The whole idea behind this is that you're not going to be able to use your calculator on the test. So really what you need to be able to do is identify the asymptotes and the position of the curves depending on if it's a reflection or not. So the more work you get, the better you'll get at this, basically. So if we just take a look at the domain, this part, so remember you're looking at from left to right, you're going to come from negative infinity, stop at that vertical asymptote, start back up at that vertical asymptote, go to positive infinity, and then you just have to have the union sign as they're working together there. And then basically the range, okay, so you got your range right here. Look at it from the bottom up. So from the bottom we go negative infinity, we're going to stop at the horizontal asymptote, -1, and then start back up at -1 to positive infinity to go above. All right, so that's the range. And then the end behavior. Okay, so again, so the end behavior, it's always x approaches infinity, x approaches negative infinity. You just tell me what's going on with the y. All right, so as my x values are getting bigger, the y value that they're going close to is -1, and that goes the same as when the x values get smaller. So as x approaches negative infinity, y approaches -1. All right, so we're going to go on to the next piece. So you can generalize this on your own, okay? So if you're going to take any rational equation, what would you say to somebody? Like, how would you get the vertical asymptote? How would you get the horizontal asymptote? What would the domain be? What would the range be? What would the end behavior? So you can come up with that on your own, and then when I see you again, which would be probably Friday, we can just talk about that, make sure you have the right answers filled in. So again, I'm going to just quit this video here so the videos stay around about 4 minutes, and then we'll move on to the next